Hi, and welcome to the channel again. So today we're going to look at part 2 in our factoring series, where we're going to be looking at the grouping method. Now recall from our first video, we talked about what factoring is. So what does it mean to factor? To factor a polynomial means to express the polynomial as a product of simpler or prime polynomials. And because we're looking at algebraic expressions, the process gets a little bit complicated. And so we're kind of breaking this up into a series of videos where we look at each individual method so that we can tackle them one at a time. So the first thing that we always do when we're looking at a polynomial and we're trying to factor is to identify the greatest common factor. And we take that, we extract it out. Now, once we do that, we count the number of terms. Now, we do that because the number of terms that we have in the polynomial is going to dictate the method that we use for factoring. Now, in the case where the polynomial has 4 terms, the most common method that we use for factoring is the grouping method, and that's what we'll look at today. So let's take a look at some examples to give you an idea of what's going on, and we're going to walk through each of those steps in these examples. So for our first example, we're going to look at x cubed plus 2x squared plus 5x plus 10. Now, in this problem, we can see there's no common factor among the 4 terms that we can extract out of all 4. So no greatest common factor. So then the next thing, we pair off the terms. So we're going to look at these 2 terms and pair them off. Once we pair off the terms, we factor out the greatest common factor for each pair. If we take a look at the first 2 terms, x cubed plus 2x squared, both of those terms have a common factor of x squared that we can extract. So we take out the x squared, what's going to be left? X plus 2. We bring down the middle operation, which is addition, and then we look at the second pair. So now what's the greatest common factor of the second pair? Well, it's going to be 5. So we extract the 5, and that's going to be equal to, and that's going to give us 5 times x plus 2. So note here, what do we have? We've got these 2 groups, and note that both of those groups have a common factor of x plus 2. So we can extract that binomial common factor, and if we do so, extract x plus 2, and then what's left over will be x squared plus 5. And there's our product, x plus 2 times x squared plus 5. And that's our factored form. Let's take a look at another problem. In this example, we have 16x cubed minus 28x squared plus 12x minus 21. So we follow the same process here as we did previously. We look for a common factor among all 4 terms. Do we have one here? No, we don't. So then pair off the terms and then look for a common factor for each pair. So in the first pair, we have a common factor of 4x squared. So extracting that factor, we'll have left over 4x minus 7. Bring down the plus. The second pair has a common factor of 3. Extract that. That'll be 4x minus 7. And as we saw was the case in the previous example, we see that there's a binomial common factor between those 2 groups, 4x minus 7, that we can then extract. So we have 4x minus 7, and what's left over? 4x squared plus 3. And that's our factored form. Now, I hope this is beginning to make a little bit of sense to you. Now, these problems were pretty straightforward, so let's shake things up a little bit to give you an idea of some of the complications you may run into when you're using the grouping method. So for our next example, we have 9w squared plus 7wv minus 9w minus 7v. Now, in this problem, when we try to attempt to pair off the terms to begin with, you'll probably notice that in the second pair, there's no obvious common factor. Now, we could, by default, factor out a 1, or a negative 1 in this case. But since we do have common coefficients, the first and third term both contain coefficients of 9, and the second and the fourth terms have coefficients of 7. If we rearrange the second and third terms, we might have an easier time doing the factoring. So let's go ahead and do that here. So let's pair off the terms here. Common factor in the first pair is 9w. Factor that out, we'll have 9w times w minus 1. Bring down the plus. The second pair, common factor here is 7v. Factor that out, we have w minus 1. And once again, we've got the common binomial factors of w minus 1 that we can then extract to get w minus 1 times 9w plus 7v. Now, one of the nice things about doing the factoring, about factoring in general, is that you're always able to check your answers from factoring by just taking your answer and multiplying it back out. If you multiply it back out and you end up with the equivalent, or the equivalent of the original problem, then you know that you factored it correctly. So that's something that you can keep in mind as a means to check your work and make sure that you're doing everything right. All right, so for our last example, we'll have a bit of a doozy here. This will be 18x squared y minus 63x squared minus 6y plus 21. All right, so now remember, before you start pairing off the terms, before you start doing the grouping method, the first thing that you want to do is you want to look to see if there's a common factor among all the terms. In this case, we certainly do have a common factor, and that common factor among all the terms is going to be 3. So let's extract that factor. We'll have 3 times 6x squared y minus 21x squared minus 2y plus 7. All right, so now we apply the grouping method here, and we're going to pair off the terms. All right, so we're going to keep everything in the parentheses. Now, to avoid confusion, I'm going to use brackets for the outer grouping symbol, since we're going to be using common factors here. So now, in the first pair, we have 6x squared y minus 21x squared. Both of those terms have a common factor of 3x squared. So if we factor out the 3x squared, we'll have 2y minus 7. Okay, bring down the minus. Now in the second pair, there's no apparent common factor. And this is a case where we could have switched the second and third terms, but if we don't have a common factor, we can always label 1 as a common factor. And so in this case, we'll go ahead and do that. So we're factoring out 1. In fact, we're factoring out negative 1. Now, remember, in the first part, whenever you factor out a negative common factor, you're going to change the signs inside the parentheses. So this is going to become, we factor out negative 1, so this will be positive 2y, and instead of plus 7, that'll be minus 7. All right, and so now we see, once again, we have the common group, 2y minus 7, the common binomial, and so then we can extract that. So bringing down to 3, we have the common factor 2y minus 7. Take that out, and then what's left over will be 3x squared minus 1. And I opted to just change the brackets back to parentheses since they're kind of out of the nested grouping symbol. And there we have the factored form. Okay, so hopefully this set of problems will give you a pretty good idea of what to look for and how to approach your homework problems that you'll be working on when you're doing your practicing with the grouping method. So remember, when you have 4 terms, we're going to be applying this method, pair off the terms, find the common factors between each of the pairs, and then look for a binomial common factor, not forgetting to check for the greatest common factor of all the terms first. So be sure that you do that. Now in the third part, we're going to tackle what happens when you have a 3-term polynomial. So if you have 3 terms, that's what we call a trinomial. And there are actually 2 different ways that we can factor trinomials depending on the type of trinomial that we have. So we'll tackle that in the next video. All right. So if this was helpful, please leave a comment, leave a like, and if you like what you're seeing here, consider subscribing as well. Thank you very much.